So we found some stones today. We're digging through, looking at things, and I found some of my Boulder opal. This is just commercial Boulder opal that I bought to set in inexpensive wire wrap jewelry that I was building, and the it's a nice stone. And it's bright too, very nice and bright. And shit. Okay, so here we are again. We've got a little diamond, very nice little diamond, kind of a clear diamond with a reddish something to it. And it looks rusty, but it's not. So anyway, what I'm going to try to do is make a scratch. See, opal is supposedly 5.5 on the Mohs scale of hardness, like glass. Okay, so here's a piece of glass. Watch this. I'm gonna have to set this down. Well, I don't know if that's going to work or not, whether you can see, but I am. Okay, glass is 5.5 on the Mohs scale of hardness. Okay, so when I wipe that off with my thumb, the scratch is still there. That's 5.5. We just tested my little thing here, and it's at least harder than 5.5. Quartz would be 7, so it would scratch opal too. Okay, and I'm not really testing my diamond so much as testing this. And when I write on the opal, it just skates across it. Because what that really is, see the scratch there? A little bit? I just put that on there. The matrix is soft. The opal is 10 on the Mohs scale of hardness, which means if it looks like something but it has different properties, it's a different thing. And what we have here is melted silicon carbide, or probably not. It is such a high melting point. I'm going to go with platinum and gold in AUPT because that melted during the KT extinction event. And, as much as I went around telling people that it was 5.5 on the Mohs scale of hardness, and when you look in a book, that's what it's going to tell you. 5.5 on the Mohs scale of hardness. To 6. 5.5 to 6. But so any way you look at it, if this was a piece of quartz, it would scratch it for sure. And it's not actually quartz, it's diamond, which is 10 on the Mohs scale of hardness, and it does not, in fact, scratch the opal at all. Doesn't touch it. Okay, I tested some turquoise a few minutes ago. It scratches like plastic. Um, that glass, look how deep the scratches on that. And I didn't put any effort at all on that. So, and it's not just that one. Let's see if I can hold it still. No, it's easier if I do it myself, Joe. Thank you. Anyway, it doesn't scratch. Let's see if I can scratch scratch the back here. And yes, it scratches the back. The matrix. Easily. You saw that. It just scratches. Does not scratch this part. Oops, come on. Just skates on it. And that is the color of melted platinum. And probably not much gold in that. It's probably just mostly platinum. The gold stayed in the AUPT. And if you look, it's got a very cubic kind of checkerboard pattern to it when you get up close. And that's because it's AUPT. It's not sandstone. Those are not separate little crystals of sand. They're not. It's a single piece of AUPT that was on the surface or in a fault line, right? The fault lines got squished pretty good in Australia because Australia was down closer to Antarctica, and the ship that caused the KT extinction event hit there, maybe first, I don't know. But it hit Western Australia, heading east, right? It was heading west to east, and it came down on the west side of Australia, and the Great Basin is where that ship hit. And it bounced. It fucking bounced and went back up in orbit. Came down again. Somewhere else, probably in China. And then it bounced again and it came down in North America. And you can look on Google Earth and kind of track it once you know what you're looking at. And like there's a big sort of oblong-shaped desert in the middle of China. I think it's the Gobi Desert or part of the Gobi Desert. And what it is an impact crater, narrow at one end and fatter at the other. It hits at the narrow end and then comes down harder and harder and harder as it's moving. And there it's, I think Asia was headed south more, because it's like it hit it going north and south from the north, or east and west, and that would mean that it reversed itself, and I don't think it did. I think it bounced off of Australia, went around once, and came down. And China was, Asia was somewhere else, somewhere further south, and headed in a different direction. And when Australia started moving, it moved, and so did India. India was down next to Madagascar, and you can see the tracks in the Indian Ocean. And tracks go right from Africa, boom, into the southern part of Asia, and then the Indian subcontinent stuck on on the bottom of it, and it created a half circle of mountains called the Himalayas. And they go from Afghanistan all the way over to Vietnam. And that's because the Indian subcontinent hit it at a pretty good clip, and it raised those mountains. And that's not like ancient history, man. The KT extinction event was not millions of years ago. This stuff was on the surface at that time. And that's why it melted. Because when that ship hit, everything underneath of it fairly close to the surface that was able to melted. AUPT has a very, very high melting point. So this got up to 1768 degrees Celsius to melt this platinum. And that's what I'm pretty sure it is. And it may be that the reason it's bluish like that is because of some radiation. Other than just like beta radiation from the platinum in AUPT. And if you hang on, we'll turn the light off and turn the one off behind me. Where to go? And we're gonna come up here. And it glows blue in the dark. And see all those little fuzzy things? Those are alpha particles. The big dots that you see, those are alpha particles, not beta emission. Beta emission's kind of red and orange and fuzzy looking. And alpha particles are first of all, they're two protons rather than just an electron. And they're things, they're like little bullets traveling at light speed. And so this is giving off helium nuclei at a pretty good clip, it looks like. That's with the light on. I am wrapping my hand around the stone. Let's see here. Where'd it go? That's more or less in the dark. I'm moving my hand now, not the phone. So when I get real close like that, it loses focus. Watch the camera. it loses focus because those alpha particles are hitting its infrared focusing system, and it can't focus on the thing close up. I can do it further away. Sort of, you can still see them. Look at that, huh? So there's no like light here in this section of my room at all. And what that is a metallic reflection. And it's beautiful too. Look at that. Isn't that neat? Hmm? People thought it was ironstone over there. That's what they call it, ironstone. Boy, look at that, huh? Wowie, man. Isn't that something? That's really cooking. Alright, with the light back on. So that's what your camera's seeing most of the time, and you don't really see the blue glow so much if you don't look for it. If you don't know it's there, right, you don't look for it. But guess what? It's there. And precious opal is maybe not precious opal at all. I have some other ones, and I'll make a couple more videos tonight, see what we can see.